Hello guys, how are you doing? Today we are on the 25th of December, still sorry, and so I wish you a Merry Christmas and I hope you are having a good day and everything is alright for you. So because I'm alone on Christmas, yeah, there are some people who are alone and I'm part of them. Because I'm alone and I don't want to waste my time. I have an idea. So I thought to myself, why not study some mathematical concept to get sharper in mathematics? So what we will do here is inspired by uh, that the example and the concept that we will study will be taken in this book which has been written by John G. O'Connor, as you can see here. Yep. So let's go. PDF. I'm sorry. So the concept study here. Anyway, I don't need that. So first of all, we will start with. Oh, I'm sorry. We will start with the concept called induction. Induction in mathematics. Induction is basically a process used to prove to prove a theory or a formula. Yeah. So how to do that? If you want to prove something by induction, if you want to prove something, a sequence for example, let's say if you want to prove that 1 plus 2 plus 3 plus 4 plus dot 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 plus n is equal to 1 over 2 times n times n plus 1. If you want to prove that by induction, then there is 3 steps or 2.5 steps, because the second step is not really a step, like you don't have to do that much. What we do here to prove that is to verify that this is true for the first term. Let's say this is called p, yeah, we call it p of n. P of n is equal to that, yeah. So if you want to prove that by induction, we'll verify p of 1. P of 1 is just 1. So if p of 1 verify the formula, then it's okay. So let's check for p of 1. The formula will be the half multiplied by 1 times 1 plus 1. So the question is it equal to 1, to p of 1? So basically what you have here is the half 1 multiplied by 1 plus 1. 1 plus 1 is 2. So 1 multiplied by 1 plus 1 is still 2. So we have a half multiplied by sorry, instead of we should be rigorous in the way we write our expression for people to not be confused. So here half times 2, and you see that it's equal to 1, so this is true. Yeah. So this was the first step. The first step was about the first step. The second step right now, or I guess first and half, the second step will be to take as true that Pn is true. We suppose that Pn is true. And then the third step is to see if Pn plus 1 is true. We have to check this. So to do so, what we can do here is let's say we have P plus 1 going from Pn. Pn, let us remember, Pn is equal to 1 plus 2 plus 3 plus plus n. So Pn plus 1 must be equal to 1 plus 2 plus 3 plus plus n and plus n plus 1, which means the term which comes just after 1. Yeah. So based on that, if Pn were equal to this, let me just copy it. If Pn is equal to this, therefore Pn plus 1 must be equal to the same thing plus n plus 1. Yeah, what we have just added. So as you can see here, we can put n plus 1 in factor. So we have n plus 1 multiply. So we have put this n plus 1 and this plus n plus 1 in factor. We will have the half of n, and in this side 1 will remain. So this part will remain. V plus the one which will remain here. Oh, sorry. Yeah. So another way of seeing that, because this if we see this carefully, no, let's see another way of seeing Pn plus 1, I mean this expression, is to take it as the formula suggests. That means we should have half times, let me be rigorous. We should have half times n plus 1 and times n plus 1 plus 1. The first n plus 1 is the term. Okay, let me write it this way. And then this one is the one of the formula. Like what I wrote here is simply the formula applied to Pn plus 1. So instead of n here, I've just put n plus 1 here to be rigorous and avoid any mistakes. Let me, okay. In fact, I don't need, sorry.